copying starts over. This is the real-time speed of the lithography machine, taking about 18 seconds to duplicate the same microchip design around 100 times across the entire area of a 300mm wafer. Let's take a look at one of these microchips and see what exactly we're copying. Inside this microchip are approximately 30 billion transistors. And if you were wondering, it's the design of a GPU or graphics processing unit found in the center of a graphics card. When we zoom into a nanoscopic view of this microchip, we find a 3D maze of transistors and layers upon layers of wires with the smallest dimensions of the bottommost layers measuring around 10 nanometers or around 45 silicon atoms. Specifically, the EUV photolithography system typically patterns the lower layers with the smallest features, whereas other photolithography tools are used to pattern the higher layers. It might be difficult to fully grasp the level of detail and complexity inside a single layer of billions of nanoscopic transistors. So let's use a thought experiment and pretend that instead of copying transistors and wires, this EUV photolithography system is used to copy the text from a book. If the width of each line of a letter is 13 nanometers, then the word cat would take up around 155 by 240 nanometers. A page of text would be about the size of a red blood cell, and a chapter of a book would be a grain of pollen. When we zoom out to see the equivalent area of a GPU chip, how many pages of text do you think we could fit using these nanoscopic letters? Well, we could print all 7 Harry Potter books, plus every book written by Stephen King, the entirety of the text from the English Wikipedia, and still have enough space to fit every single book from your local public library. There's an unbelievable quantity of nanoscopic lines and details that can fit into the area of a microchip, and it's all photocopied by this EUV lithography system in less than a second. It's no exaggeration to say that every piece of modern technology that you use is made possible by this machine, and in this video, we're going to explore the key modules inside it and see how they work. So let's